Okay, hi, grade ninths. So this is week 2 of inequalities, June 3rd to June 10th, and it's video number 2. So we're gonna just go over rewriting complex inequalities. This is like the ones with 2 boundary points, okay? And we'll also talk about graphing them. Okay, so let's get into it. First of all, I want you to realize that inequalities can be reversed. So here's what I mean. If you have, let's just take a simple one. 4 is less than 9. That is the same thing as saying, if this is true, isn't it also true then to reverse it and say 9? Let's start with a 9, but then reverse the sign and say, isn't 9 greater than 4? So you have the less than version, right? And if you do the reverse, so you're going to do a little reversal here, reverse, and you can restate the same relationship in terms of greater than. So okay, so in other words, go back to Mathematics 101, guys. Is this true? Right? 2 plus 1 equals 3. Is that true? Is this true? Yes. Okay. So inequalities can be reversed. All right. With numbers, you only get a choice of less than or greater than. All right. Let's just do one more. Let's see. -2 is greater than -6. Okay. So -2 is greater than -6, right? -2 is warmer. -2 is less det. -2 is closer to the 0 than -6, okay? So I kind of put that -6 a little bit far away. But you can reverse that, okay? You can also say at the same time, right? So you can say reverse. You can reverse this and say at the same time, the reverse is true, okay? So in other words, -6 is less than -2. So you swap the positions, right? This one went here, this one went there, and so then you flip this sign, okay? So you flipped it. So I'll write it over here, flipped it. Now with variables, well, before I get into variables, you cannot, with numbers, okay, with numbers, you can't, and like a lot of this is just common sense, right? You can't use less than or equals to, like 2 is less than 6, that doesn't make sense. There's no way 2 is equal to 6, okay? And with, saying 3 is greater than or equal to -4, you can't, that doesn't make sense anyways. Well, I mean, you can't reverse it, okay? You can't say that it's equal to negative. One of the possibilities is not equal to -4, okay? So it doesn't make sense to reverse it. But you can do it with variables. Okay, you can do it with variables. So let me just show you what I mean here. If you say, for instance, x is less than or equal to 4, then you can go ahead and reverse this and say this is also true. 4 is greater than or equal to x. Okay? 4 is greater, because you're saying the possibility here is x could be 4. So 4 makes sense here and 4 makes sense here. Again, you could say -2 is, no, let me start with the variable, pardon me. Okay, so m, let's go with m is supposed to be greater than or equal to 6. And again, the reverse is true. 6 is less than or equal to m. Okay, the reason we talk about this, why it's important to know that you can reverse your inequalities, is that if you have a situation where there's 2 boundary points, right? So here there's 2 boundary points. Okay, so that's supposed to be letter N. 2 boundary points. I'm just going to abbreviate that as PTS. Okay. However, this is a bit complex. Like you've separated them by a comma. You can actually glue this together and get this into one sentence. Here's how you do it, okay? First of all, just rewrite the less than part. Okay, the less than part. So here's what I'm saying. Just write x is less than 9. All right? All we did was write x is less than 9. Now over here, let's use green. Okay, you're going to reverse this one so that it's written as less than. In other words, you're going to get all the signs to be of the same family. All the signs got to be greater or greater than or equals to, or the signs are, all the inequalities are going to be expressed as less than. So express your inequalities all as greater than or all as less than. It doesn't matter, but I tend to favor less than. And there's a good reason for that. Okay, so in other words, this is the same as 1 is less than x. Okay? So that means you can put it all together, okay? So you can put it together. And what does that mean? Okay. So just rewrite your one of the we'll call this part 1, here's part 2. Just rewrite the first one that was already written as less than. Then write your x here. See, this is my x. I'm going to write it there and write 1 is less than. And the neat part is that when you write it like this, with your boundary points on the left and the right, just like they would be on a number line, then you don't have to repeat this x. In other words, you can just write this. I call it the inequality sandwich. Okay. Okay. So it's called the inequality. That's my term. It's not an official term. Obviously, Mr. Smith is making it up. In other words, you can just write 1 is less than x. Sorry, let me just make that a little bit nicer. 1 is less than x less than 9. Okay. So you can write that all together. Let's use orange here and let's make it nice and thick. So this is an easy way of writing this, right? You have two separate parts separated by a comma. Actually, you can just make one little inequality sandwich, one sentence, okay? So let's do that again. Here's another example. I gotta make sure my pen is back to being skinny. All right, so quickly, I'll just show you it. The part that already has the less than part, just rewrite that, okay? Now, the part that has the greater than or equals to, just rewrite that, do a little reverse, okay? And just restate the relationship in terms of less than, okay? And then you do what the stack and combine part to make your sandwich. I just had a sandwich for lunch. Maybe that's why I'm all oriented about the sandwich. So take the reverse relationship and write it. Make sure your x's are stacked up. It's almost like adding, like terms a bit. So then you're going to say x, negative 6 is less than x, less than or equal to negative 2. Okay? So again, this is the final result. This one little thing is the same as writing it out separately. Okay? Example number 3. All right? Example number 3. So I'm going to just write it like this. Watch. I'll just do it immediately without all the in-between work. X is less than 3. Okay? Flip this. So I'm going to write x on the right. Okay? This is going to flip. And then the sign also flips. So x is less than or equal to negative 3. Okay? Now stack it up and just write one common sentence. Negative 3 is less than or equal to x less than 3. Okay? I'm not going to get my huge, thick orange pen. I think, hopefully, cross my fingers, you're getting the idea here. Okay, one more example. I think this is the last one, and then I'll show you the graph. Okay, so this is already written with less than, okay? So this is good to go, GTG. This is good to go. So over here, x is less than or equal to negative 2. Now I'm going to do my little switcheroo, flipperoo, swapperoo, whatever you want to do. And we're going to write negative 5. Instead of x being greater than or equal to negative 5, now we've got negative 5 is less than or equal to, and now we're going to make one sentence. Negative 5 is less than or equal to, you don't need two x's anymore. X occupies the middle position. That's why it's the middle part of the sandwich. The numbers are the outside pieces of bread. Don't you just love my analogies? I know you do. Okay? So that's one way of rewriting the separate boundary points all together. And this would be the left side, and this would be the right side. Okay? I'll show you what that means. 1 is less than x less than 9. Okay, So this is supposed to be left side. This is supposed to be right side. It's really done like in a convenient way. That's why I use the less than sign, because it just goes from left to right. So here's a circle at 1. You don't have to decide right now if you want to shade it or not, but when you get good at it, you'll know right away. Look, this is supposed to be an open, right? This is open. This is open. So we're not going to shade either of these. Now, we are going to connect them though, right? All right. So there's the solution. In other words, x must be between. And that's the other way, that's the other reason I like it, because this x kind of shows, it kind of almost, whoops, got to switch to a pen here. The x actually shows that it is between two boundary points. That's the advantage of writing it this way, okay? There's like a literal physical way of showing that x is between these 2 points when you stick x in the middle, okay? So this is the solution that is good or viable, and anything outside the boundary points are no good, okay? So the solution exists between 1 and 9, does not include 1, does not include 9. So you could have 1.01, and that's a viable solution. You could have, of course, 8.99, and that's a viable solution, okay? So that would look like this. 1 is less than 1.01. That is true. And at the same time, 1.01 is less than 9. So I substituted in for my x. Let's do this one. 1 is less than 8.99, and that is less than 9. Okay, again. So obviously it's just slightly, obviously I used exaggerated examples to just show you that technically that's a viable solution, that's a viable solution, right? 0.9 does not work, right? 9 itself does not work. 9.3 doesn't work. 10 doesn't work, right? And you get the idea. Okay, over here. Now, just again, at this point, just pay attention to your boundary points, right? So you just got to pay attention. Do this. Your boundary points, BP, not Boston Pizza, but boundary points. And then pay attention. Is it open versus closed? And yes, you can have combos in the same question. So boundary point here. Boundary, I'm going to make these pink because they'll stand out a little bit better. And then I'll make this just a little bit thicker. Okay. So 6 and 2. They're your boundary points. All right. Now -6, I'm supposed to shade in. 2, I'm going to leave open because, look, I'm just following a direction. This is like a recipe, okay? This is like a recipe. Just follow what the recipe tells you. Let's use a straight line here so I don't get too messy. Okay? So again, your solution exists. All your allowed solutions, all the viable solutions are between right here. Okay? Whoops, let me just go back to the pen. Okay, get that off, make this a little bit smaller. Okay, so -6 is a viable solution, okay? -5.9 is viable. Let's start going into fractions. 1.5 is good. 0.47 is good, right? But 2 is not allowed. 2 is not included. We left it open. So over here it's open. Over here, right, it's closed. Okay, so it's all about whether it's included or not. -6 is included as part of the solution because the or equals to part. Next one. Okay, I think you guys are probably getting onto this at this point, hopefully. So -3 is your boundary point. +3 is your boundary point. This one is open. This one is closed, so I better shade that in. So let's shade that in. And then where does the solution exist? Okay. Right there. All right. So every x value between these 2 points, including -3, but not including +3, all right, is a viable solution. Okay. Nothing is good over here and nothing good over there. The solution only exists between your boundary points. Okay. In high school, you'll get more complex stuff where, you know, the boundary points will be separate, but I'm not going to touch that today. Okay, last one. I think this is the last one. So -5 is less than x. Really, all we're doing here is just testing you on whether these boundary points should be open or closed, right? And this one should be closed, and this one should be closed. So both of them should be shaded in, and draw your line. Okay. And yeah, that's it. I think that's, yeah. So the next video you can see is video 3. All right, grade 9s, video 3 is coming up. Hope that helped. And we'll see you next video. Okay, take care.